Okay, right. So before we begin, I would like to ask you a small question, Dilmi, Tenuka both. So have you done coding before? Any kind of coding? Have you done that before?
Just a little bit.
A little bit, yeah. May I know, so is it like Python or?
I know a little bit of Python.
So what about you, Dilmi? So you also?
No, I haven't done coding.
You have not done, right? Okay, that's okay. That's perfectly okay, because we are going to start from the beginning, and so we'll be explaining things from the beginning, right? So actually, I have a common note which has like both Sinhala and English. You can ignore the Sinhala medium one because you are learning this in English medium only. You can ignore this Sinhala medium wording because everything is there in English medium, right? So don't worry about that. Okay. So before we begin, I would like to introduce the topic to you first of all. So this subject of coding is actually it is the main discipline is software engineering. So coding is actually a step coming under software engineering. So I think you know the word engineering. So engineering and building. So if I tell two words, engineering and building, so can you distinguish? So what is the difference between building and engineering? So what's the main difference?
Is engineering like the thought process behind building it?
So what about building then? So
Actually,
which is primary? So which is primary, building or engineering?
Building.
Building, yeah. So I think you have played with building blocks in your childhood, right? Building blocks, you know, that small blocks,
yeah,
which is created, yeah, it's twice, right? Then actually you don't have something called engineering blocks. In the childhood, you are not using engineering block, but we are using building block. Building block means like then and there, when you want to do something, then and there, you can start doing it. If you want to, like, for an example, if you want to create a software, you go to the computer and start coding and create the software. So that is something like building. But software, we are not actually promoting that approach for software, as software is critical. So if you see the world statistics about this industry, information technology, so these are the top 10 richest. So let me change the language. Top 10 richest in the world. You can see. So this is changed in time to time. According to June 2022, Jeff Bezos is number 1. So do you know him? Jeff Bezos is from USA. So what
yes.
he's doing? He's
Amazon.
Amazon, yes. He has developed Amazon. He's the owner of Amazon. And Amazon is like e-business space, right? E-business space. And actually it is. So these are, we call .com companies, because these companies need not to have like large buildings, storefronts. So no need to have such. They have online store. They are operating 24/7, all 7 days available. And it's available worldwide, everywhere. Regardless of the geographical location, you can purchase, you can sell and buy. So these are called .com companies. Actually, he owns a .com company, Jeff Bezos. Bill Gates, who's him? Bill Gates.
Microsoft.
Again, yeah, again from USA, Microsoft. So Microsoft, he is in the second place. So Microsoft, again, there is a software related to information technology. Jeff Bezos related to IT. Bill Gates related to IT. And so then let's keep these 3 people for the moment. And if you say Larry Ellison, Larry Page, and Sergey Brin, so 2 are working for Google or Alphabet, and 1 is for Oracle company called Oracle. That is a database related company. That is also IT. And Larry Page, Larry Ellison, Alphabet or Google, that is also ICT. And if you know Mark Zuckerberg, he was also there in top 10. He is also related to ICT. So top 10 people, most of the time when we analyze top 10 people, more than 50% are related to ICT and also related to software, mostly, right? So that is the thing. Means, so we can come to a conclusion with this. So world's most valuable resource. So world's most valuable economic resource is none other than information, right? Information means processed data or meaningful data is valuable and used in decision making. And so do you know Red Data Book? Red Data Book? Have you heard of it?
No.
No. Red
No.
Data Book is actually, it's a special book maintaining details related to endangered species in the world. Endangered species in the world. So means like some species are vulnerable, you know, some species are rare. Some animals, some plants are rare in the world. So those plants, animals, they are vulnerable, and they are sometimes, because of this rareness, they are categorized under endangered species. The details related to them is there in the Red Data Book. That is not a red color book, basically. It is a book with some more information, but red is a color, right? When I tell red, your head will be filled with the color. But Red Data Book is not about the color. It has some more meaningful thing, right? So that is the nature of information. Because data, you cannot do much with the data. Data are basically raw facts. But information, meaningful. It has a meaning, it has a value, it is used in decision making, likewise. Okay. Anyway, so if you knew about the COVID-19 virus, when it was initially came to the world, if you knew about that, and if you knew how to create a medicine, you will be in that top 10, right? By today. So what do you need to know? Information. So it's not about COVID. It's not about the virus. It is about information. If you know how to deal that, if you know how to treat that, so that is information. If you knew that information, you will become one of the richest people in the world. So that is the nature. So therefore, this information is really valuable. Okay, I'm preparing the background. So we have data, raw facts, information, process or meaningful data. Actually, this abstract model of information dealing with converting data into information. Any information system take data, process it, and convert it into information. So where's the software? So still you couldn't see the software part. Data is converted to information. Why? Because information is one of the most valuable resources. Data are raw facts, information, meaningful data or meaningful or processed data. So conversion process is called processing. So where's software? Still you cannot see software. Data processed and information is created. What is the engine? Engine is the software.
Okay.
To do that, yes, you need an engine. So that is software. So data processed, information is created. So Bill Gates working with one engine, Microsoft. He has range of products under Microsoft. It can take data, process, and produce information. And then Jeff Bezos, then he has like the initial things about maybe about the goods and services that he's providing through the Amazon website. So he organized that and presented as information. So engine is this Amazon. Amazon is a software. It's a web-based software. Microsoft, Windows is a software. Microsoft Office is a software. Okay. So then this part, I'll be sending this note because like this is, we are doing 1 hour class. And so if whatever important you can write down, that is okay. That's totally okay, whatever important. The key points you can write down, but I'll be sending the note to you, right? Software is basically a set of instructions. That is what we are going to write. In childhood, basically, we explain software just as set of instructions, but when you are drawing, you have to tell more. Software is not just set of instructions. It is set of instructions plus related data structures and related documentation. This is very important. I think you can write down this because like there should be some entry to the lesson. So please write down the main heading software engineering in a note, software engineering, and then software. So what is software? Software is a set of instructions, related data structures, and related documentation.
So can I write it on a notebook or on the computer?
Yeah, you can write in the notebook or you can write in the notepad, wherever, whichever convenient to you, you can write. Either you can write it digitally by typing, you can enter, or you can just write it in your book. The main heading is software engineering. I'm highlighting what you need to write. This you need to write, the main heading. Then this part. So what is software? That part also you need to write, right? What is software? What is software? It's a set of instructions plus the related data structures plus the documentation. Okay. Sorry. Okay, Microsoft Word is an example for software. Right, Microsoft Word is a software. You can see this with Word. So you can see this, there are some buttons, menus, pictures here, different shapes. These things are there. These are actually the data structures related to this software. These are already created data structures. Right, you can see Word darts. So different things are with not just the software. With the software, you have table structures, different shape library, models, smart arts, different smart arts, charts. So these things are there. So these are actually data structures that you can just think as data structures. But so this is just overview, right? Okay, then the documentation means, right, the help. You can tell that as a documentation. Here, tell me. Right? You can just, so this is a part of documentation. You can get help. So when you go to help, so let's say I want to know how to insert a picture. How to insert a picture. If I browse, I'll get help related to this. So that is actually documentation. You can see here, insert pictures. This explains how to insert a picture into Word, PowerPoint, or Excel. You can see these step-by-step instructions. Then you can read it out and understand. So that is belongs to the documentation. Right? Not just that, there are many things in the documentation, but one example is help. So the data structures, one example is these buttons and all. The shape libraries, the pictures, clip arts, all these are the data structures. Instructions. That is what we are going to write. Okay. So let me explain the criticality of software further. So so for an example, if a doctor fails, if it is a critical failure, patient might die. If a doctor fails, maybe let's say a doctor is doing an operation and he failed to do that, patient might die. But what happens if a software fails? Many people can die, right? So that is the thing. That is why the software engineers are paid highly. That is why software engineering is a demanding thing in the world. Because if a doctor fails, maybe that is subjective. So 1 or 2 maybe. So it's not, he is not going to, it's not going to affect a big portion of the society. But here, if a software fails, So that can be even be a disaster. So let's say here, this is an example, Boeing 73 Max software issue. You can just Google it. So Boeing is a leading company engineering flights, and this here killer software, 4 lessons from deadly 737 crash. Few Boeing flights have crashed. So the reason that they have discovered, they think that the main reason for that was issue in the software. It's not error actually. So certain understanding about the software and the inputs and outputs has affected the crash. Because of this crash, all the passengers died. Not just single flight, there were around like 3 or 4 flights. So they had to land all the 737 flights. So if you search the story, they have to land. The company has to land everything. Right? They after that there was a court case. After 6 or 7 months only they could fly again after solving this problem. So see the criticality. So if this error happened in a world bank or central bank somewhere in a banking software, maybe entire country or the organization can fail. Right? Let's say your bank account has a balance. Your bank account has, let's say, 10,000 USD. Right? So maybe due to an error, bank has additional 0 added to this. Wow, you are lucky. Right? So if this happened to all the clients, then the bank will go bankrupt, right? Because adding 1 0, 1 extra 0, that is a software, that can be a software issue. Who knows? Therefore, this needs careful engineering approach. Right now, we know the information. Information is none other than the meaningful data or processed data. So in information model, abstract model, data is converted to information. Actually, software is used in this process. Throughout the process, software is used, and software engineering is a critical task. Why? In case of a software failure, there can be life-affecting issues. People might die, companies might fail, countries might fail, right? It can ruin the world, ruin the lives. So that is so dangerous. Therefore, software needs careful engineering approach. So don't think Word is only used by us. Word can be used by Microsoft. Word can be used by Facebook. Word can be used by president of USA or some other country. So they are using Word. So think failures. Word can be used by World Bank. Pentagon is using Word. Right? Pentagon is using Word. So if failure happen, affecting everywhere. Okay. Then, so in this, we are going to learn about how engineering happens. Actually, the first lesson would be some more theory, less practicals, right? Because I have to anyway give the foundation. Without giving the foundation, I'll be not able to deliver this very well. That is why I'm setting the foundation. And again, since who like Dilmi, I think Dimi or Dilmi. So how can I pronounce your name? Is it
Dilmi?
Dilmi, right? Okay. So since you have not done this, then that is why I thought, yes, let's do the introduction, and after that we can start coding part. So next day actually we can do the coding, but today we have to set the foundation. Okay, software process or software development process is a cyclic process. So everything in this world has a cycle. Even the world has a cycle. World has a cycle, renewing cycle. Solar system has a cycle. Sun has a cycle. Moon has a cycle. Right? Everything in this world is a cyclic. So carbon cycle, I think you know. Water cycle. So it is cyclic. So similar to that, the software is also a cyclic process. In this software engineering process, the first step is identifying the problem. Right? In this you have to carefully understand what is the real problem. Okay, I would like to give you small, small kind of example for this, right? So let's think like this. Okay, when Homo sapiens, even before Homo sapiens, you know, in the human evolution, so what was the initial need? What were the initial needs of human? Yes, what did they expect? Think about 5,000, 6,000 years ago. People in maybe 10,000, 20,000 years ago. So what did they expect? Yes.
Did they expect nothing?
Yes, they expect nothing, but definitely food, right?
Yeah.
Food. Yeah, because
And water.
yes, they want to survive. Food and then is it enough? Food and water. Okay, beverages, food. Is it enough? Was it enough?
No,
Was it-
they needed clothing.
Clothes, yeah, but before actually they didn't. So they were like monkeys, right? They were like monkeys, but they, of course, they expected food and a place to live, a shelter or some maybe a cave somewhere, a place to live, plus food. And actually every species, they were fighting between the other species to become the leading species, right? So, you know, lions, they are fighting. So they want to become the leaders. Then tigers, they are fighting. Likewise, the birds, they are fighting for their survival. And people, Homo sapiens, they were fighting for their survival. So they needed three things: food, shelter, and reproduction. Producing their own generation. That was compulsory. Otherwise, they couldn't fight. No, they will not extinct. They will vanish. So if we are not producing our next generation, then what will happen? Gradually, there will be no human beings in the earth. So reproduction is one. Reproduction is a need, was a need, food and shelter. Okay, the problem that they had initially was food, because you know, when they are generating their own generation, then the population was high. When the population was high, the resources were less food. Okay, so let's take that as a problem, less food. So what are the requirements to solve this problem? What can we do to solve this problem? The problem is not enough food. Then how can we solve that? Just think about the ancient people, right? We can buy, but they couldn't know. We can buy food, we can order food, but they can't, they couldn't. What they did? Can you imagine what they have done?
Hunt for food.
Yes. They had to find food anyway, right? So they had to hunt. They had to move from their current place to some other place because not enough food. Okay, let's say, for an example, let's say, so let's think this as, okay, this is their tribe. The tribe, the people are here in this tribe. So they don't have enough food, so they need to move to some other place. When they are droving, they need to, right? When they are droving, they need to move another place. Likewise, they were spreading. Actually, to move, the problem, initial problem was food. It has caused different requirements. You need to move. To move, you need roads or paths. Initially, it was food path. The system designing. Designing means they had to plan. Okay, we need to move. How we can move? People were thinking different ways of moving. So what are the ways of moving? What are the ways of locomotion? Different animals. Walking is one thing that is actually for us, no? So what are the other locomotion strategies other than walking?
Horse.
Sorry?
Horse.
I'm asking about the ways of moving one place to another place. Flying. like flying, swimming, tripping. Are you getting my point? So these are the other ways of moving, right? They could fly, walk, trip, tripping, flying, walking, maybe hopping like frogs, they are hopping, like fishes, they are swimming, birds, they are flying, right? Different ways of locomotion. But what is the most feasible for human, flying or tripping? Tripping, is it good? Flying, is it good for human? Or
No,
walking?
walking.
That's walking. So this is called feasibility study. Feasibility, understand these things carefully, right? Initially, you have to identify the problem. The second thing, you need to identify the requirement. You need to move. How can we move? The method, how to do that. From the alternatives, find the best alternative. How can we move? Can we trip? Can we fly? Can we swim? No, better we walk. Then the plan. Even when you are creating house also, first of all, you have to create a plan. Can you live in a plan? Can you live in a plan? No, plan is not actual, right? The plan you need to develop. This is where you are going to learn coding, understand the pace. Right now we know several steps. In which pace we do the coding? System development phase, right? System development phase, we do the coding. After doing that, you need to test, because nothing can be executed without testing. That is not good, because this is critical, right? You need to test whether it's working properly. Finally, if all are done, you can hand over. So ancient people, they were searching for food, they were planning how to move, they have planned, they created roads, they tested them, they have handed over that to their tribe. Finally, they have to maintain, because time to time, you know, different issues can come. No, the roads can be damaged, flooding can be there, maybe some different, like, you know, you need to clean it. Likewise, maintaining is required. Everything. So this is common to everywhere. In a software also, first you have to identify the problem, then the requirement analysis, and after that the plan. After planning, you do the coding, and after that testing, deployment. Deployment means hand over that to the user, and finally maintenance. Okay, shall you write down these steps, please? Right. So only write down the numbers. So I'll highlight again. Software process is a cyclic process and it's called SDLC. So this part you need to write. Then SDLC steps, system development or software development lifecycle steps. And then please write down this. The first stage is identifying the problem. Second stage is requirement analysis, planning, system development, testing, deployment, and review and maintenance. These are the stages of SDLC. Only the highlighted point, right? Don't write down the other things. Other things are not needed. Just write the highlighted points. Write the highlighted points. Tell me once you're done. Okay. Finish? No.
Almost.
Okay. Just indicate once you're done.
I finished.
Okay. Right. So these are the steps. And now we know where the actual coding happens. It happens here. Right. So now we have broad idea. So under this ICT subject, we are going to learn about information. We have learned about information system abstract model that has data, process, and information. To do that, you need software. So we learn what is a software. Software is not just instructions, it is instructions plus documentation plus data structures. Software need to be engineered. It uses a cycle called software development life cycle. It has several steps and we learn about them as well. Okay, now 50% of our duty is done. Foundation is over. 50% of our foundation, not just finished, right? Then, right. Then we need to know about how to create a plan. Okay, this is another example of this cyclic process. Initial version that I have used in I have used operating system called MS-DOS. I'm not sure whether you have used. So which version you have used? Have you used Windows 95, 98, MIEEE, XP, 7, 8, 8.1, 10, which one?
I've used 7, 10, and 11.
Right, 7, 10, and 11, right? I have used MS-DOS 3.1, 95, 98, Windows Millennium Edition, XP, Vista, 7, 8, 8.1, 10, and 11, right? So why there are so many versions? Because of this cycle. The first cycle DOS. So once this cycle can no more support the functions, a new cycle begin, 3.1. But that will also be ended. Then the 95 came. So 95 is nice interface, but after that, so the functionalities was 95 was not enough. Then the new version developed, that is 98. So that has more features than 95, but even after some time, that is also. So now we are in Windows 11 era, but do you think that they will stop from Windows 11? No, next year or the next year, there will be new version, which will be addressing new needs, maybe IoT, Internet of Things. So there are new things happening in the world to help and cater that new world, the new version will come. Okay, so these phases I'll be explaining. I have already explained what is done in each phase, but I'll be keeping that to the next day. And today, because these are not difficult, system analysis is basically how you find out the requirements, right? How you find out the requirement, that as a process. But in this level, you don't want to concern much about that. Then finding the requirements. There are two kinds of requirements: functional requirements, non-functional requirements. Functional requirements means what you must do, what the system should do. Those are functional. How it should be achieved is non-functional. Okay, for an example, functional requirement of what is your functional requirement? You need to learn programming, right? That is your functional requirement. Your non-functional requirement means you need to learn this, right? You need to learn this. Maybe you both need to learn this in English medium. That is non-functional requirement. That is not a compulsory, but better you have that environment. So that is it. So you need to learn programming is functional requirement. Learning this in English medium is how you should achieve that. So that is better to have feature. Must have feature is functional. Better to have feature is non-functional. Okay. Then the system designing. Today we are going to learn that as well. In the designing phase, similar to house planning, we have to create a plan. In this planning phase, we are going to use a planning tool called Flowchart. Have you used that in your school? Flowcharts?
I think in math.
Right. Okay. So then this flowchart is a tool which is used for the system design. So these are the symbols in this flowchart. Start and stop is using a ellipse or rounded rectangle. You can show the start stop. Process is showing using a rectangle. Input or output is shown using a parallelogram. Decision is using a diamond connector. Connection using a circle, and data flow using arrows. Okay. Right. So please write down subheading. System designing. System designing. So in the design phase, please write down this. We are using tools such as flowcharts, pseudocodes, and UML diagrams. So these are used in the system designing phase, planning phase. Okay, please write down the highlighted points. System design. Finish?
I finished.
Okay.
Yeah.
Right. Then the flow chart. So you should know why we are using flow chart. No, we can explain. Anyways, this designing can be done using any mechanism. Any kind of diagram can be created. So even the system designing can be written in natural language, like English. But we are not going to do that. The reason is the natural language can cause ambiguity. Okay, so natural language can cause ambiguity. That is the main issue why we avoid natural language. For an example, right, in Sinhala, there is a statement, common statement, I'll use that in this ancient era of this one of the kingdoms. Some soldiers, some enemy soldiers were captured, and actually the army leader, the commander has sent a message saying this, Maran epa nidahas karan. So this is one example, right? So commander has sent this kind of message. But what has happened actually? So the particular person who read the message has read like this, read the message like this. The idea, he read like this. He thought, kill, don't release. Maranna epa nidahas karan. That means kill, don't release. But actually the message was, don't kill, release. Right? So see the ambiguity. One message can carry both meanings. So actually he was sent the message with the idea, don't kill, release. But the person read that kill, don't release. So that has ended the life, right? That is the thing. So natural language has ambiguity. Natural language has ambiguity. So the idea that we want to tell might, if it is ambiguous, the ultimate system that you develop will fail. Therefore, you need to use minimum amount of letters, minimum amount of words, and explain the software. To do that, flowchart is used. Right? We can explain plan using the set of symbols. Reason for this is to reduce the ambiguity in natural language, and we can explain plan using minimum number of words. We can explain the plan using minimum number of words. Please write down. So especially when you are using flowcharts, that is the idea. Okay. And also write down these flowchart symbols, this part. I'll highlight that again, this part, flowchart symbols. Please write down this as well.
I finished.
Okay, I hope you have finished drawing the symbols as well, right? Right, okay, good. So let's see how can we create a flowchart, small flowchart, and how to convert that. Actually, we have three ways of implementing flowcharts. The first way is called sequence. You can see instructions can be executed, can be placed one after another. It's going down one after another. Sequence instructions are executed one after another in a sequential order. That is the method one. And selection is where the instruction flow has a condition. Well, example, let's say you are at a junction. You are at a junction, and in this junction, you need to decide whether to turn right or left. If you are at a junction, you need to decide whether to turn right or left. You can't go both directions same time. Can you go right and left both same time? No. Either right or left. Or you can go to right, then come back to the left. But simultaneously, same time, you cannot go right and left both sides. That is the nature, right? Simultaneously, and the same time, you cannot move right and left both. So, sequence is where the instructions are executed one after another. Selection is where instruction flow is selected based on a condition. It's like this, either to turn right or to turn left. You have to decide. Repetition is doing things again and again, repeating things again and again. So these are the three ways of organizing symbols in a flowchart, right? So let's do the first one first, and then, yes, we have enough time. We can convert this to code as well. So let's try to convert this to code as well. But before that, so please note down this part, control structures in programming. So there are three ways that you can organize the code: sequence, selection, and repetition. So let's do the first one first, and then next two we can do next day. Okay, please write down this and also write down this question right under the sequence. The first one, please write down this question. Okay. I hope, right?
Yeah, I finished.
Okay, sequence. The first example given. Draw a flow chart and write pseudocode and programming code to programming code in Python to input 3 numbers and add those numbers. So total and average must be displayed at the end, right? So you are given a task. First of all, you have to input 3 numbers. Here, see, I have used the symbols. Input symbol is this one, no, parallelogram. Start symbol is ellipse. Input symbol is parallelogram. I have an input 3 numbers, N1, N2, N3. So these are the 3 numbers. Then I have added them, total and average. Total is actually 3 numbers. Average is total divided by 3. You can get the average value. And finally, output. Output is again a parallelogram. And stop. So this shows the data flow. The arrows shows the data. This is how we draw a flow chart. Sometimes you might have done this in your school, right? Sometimes. This Vinaga said that he has done, not sure, right?
I don't know.
Okay, please, please draw this. Please draw this quickly. Let's see how can we convert this to a code in there. Have you downloaded and installed Python?
Yeah, I did.
Demi, what about you? Have you downloaded?
No.
No, right. It's okay. Let's download it, right? Okay. Pseudocode. Pseudocode is some code, like it's a code with text. It's not actually running code. You just write whatever here, you just convert that to a text. So writing same thing in text. Just see this. We have created this one. Just see the pseudocode. It's very, very simple. Yeah. Begin, input N1, N2, N3, and total equal all three, adding all three, and average equal total divided by 3. Then print in this total and average and end it. See how simple this is. That is pseudocode. Just write in the same without the symbols. Just write down the same without the symbols. Okay, write down pseudocode as well. And since you have not downloaded Python, so Python programming can be done few ways. So one is you can do online, but online version actually for today we can use that. Right, for today you can use that. So let me give you a link online Python compiler. Okay, you can use this online GDB compiler, this one. Prefer this one. I have sent you the link, right? I have sent you the link. If you need this one, please take a screenshot. Take a screenshot. Later you can write down. Flowchart and pseudocode. Please take a screenshot. Okay, let's do the coding now. Right, first of all, you have to take 3 inputs. So let me go to the coding interface. This is online one. So if you have downloaded, that is okay. If you have not downloaded, just use online one that I have sent. So the first thing is I'm going to erase everything here. And I'm going to mention N1 equal input. Within bracket, within quotation, I have to give the message enter number 1. Similarly, you can get other 2 inputs, N2 and N3. Okay. Find in the total. You can say total equal N1 plus N2 plus N3. Okay, let's print the total. Simple p print. Capital simple matters. Please note capital simple matters, right? Print total. Right. So that will print the total as the output. So this is to print the total, but average part I have not done. So shall we try this code quickly? Once you're done, please tell me. I'll give you a chance to share your screen. Then you can show me the code. This is very simple, the first exercise and very first code.
I finished.
Okay. You can share. Then okay, yes, you can share. Okay.
How
To
do I run it?
execute that, you can click on run. Green color button. That's correct. Then you ask, just enter number 1. You can put any number. Second number, again same message, right? Okay. So can you just change it to number 1, number 2, and number 3? The message, the green color one. Second line, third line, you can't change there. No. You have to alter it here. Display 2 and 3. Yeah, stop it first. Stop using the red color button, then you can edit, right? 2 and 3. Okay. Then run it. Yes, now you can put numbers. Okay, so is it correct answer? 1 plus 2 plus 3. Is it 1, 2, 3?
No.
No, actually it has. So the problem is it's not mathematically added, right? Okay, let's see image code now. Can you share? Jimmy? Yes, can you share? Okay. Still loading, so. All right, okay, I got it. So can you just, can you run it? Oh, there's a small mistake today. So can you see here, N1, again N1, again N1, right? So this will execute, but the problem is, right, you have to stop this and first off, stop this. Stop using the red, otherwise we can't edit, because while it is running, you will not be able to edit. So stop it and then put N2 and N3. Okay, now run it, and you are prompted the message to input some numbers. You can put any number. Yeah, let's put 10, 10, 20, 10 and 20. Enter, press enter key. 20 there, or some other, whatever number you prefer. You can put anything. Okay, press enter. And you can see, oh, small thing. Again, that mistake, the reason is, yes, the reason is here simple entry. I said that capital simple matters. All right, okay. Run it again. So when you get errors, don't worry. If you're getting errors, that is good, because errors are also part of education. Now you can see when you add the numbers, it is 10, 20, 30. It is incorrect, right? Because that is not the way that you should add numbers. To do that, you can add small part to the beginning. See here, you can put int, something like that. You can write n1 equal int input. Then you can say enter number 1. And make sure close both brackets, right? So can you edit like this? N1 equal int input, enter number 1. Int, then the bracket, input, bracket open again, and close 2 brackets. Okay, do the same to other 2. That means N2 and N3 both. N2 and N3 both, please added. Yeah, okay, good. The third one, int input. Okay, close it. Right, now run it and see. This int says it's an integer number. It's an integer number, whole number. Now you can put the numbers. When you add them together, you can get just correct answer. 10 plus 20 plus 30 is 60, correct. Yeah, this is how to add. So now can you think and show the average? How can we see the average? You can see the flow chart or the pseudocode. It has the idea. Just how to get the average. In line 5, you can write that. Line 5, you can write average calculation. Average equal, yes. Average equal total divided by that you can add. Make sure to use the same capital simple letters that you have used. Average equal to, yes, what? Total divided by 3, right? So total, you know the total, that if you divide that by 3, /3, yes, correct. Then you can display the average. To display the average, you can go to the 7th line and print it. Print average. Go to the 7th line, print the average. Okay, good. See, it is not difficult, right? So run it again. It's not difficult, but it's working according to the plan. When you have the plan, you have to execute. All right, now you can see the total is 60, average is 20.0. Okay. This code you can write down in your book. Right. What about your coding? Have you finished, Tenuka?
Yeah.
Okay. You can share.
Okay.
Okay. If not mistaken, then the code should run perfectly. Yes. Yes. Correct. Yeah. You have some mistake there.
Huh?
Capital simple matters, right? I said that. So if you are using capital T total, the other two you need to change as capital T total, right? Yes, that one and the next one need to be changed. Okay. You have to remember. So whatever you are using, it is case sensitive. The capital and simple matters. Now we can put the numbers and see. Okay. Total is 6 and average is 2. If you want, you can make it meaningful by just go to the beginning of this and you can add something like this. Let me add print total is, then a comma, and you can write the total. Then that will be more meaningful.
In the beginning or the end?
In the beginning, yeah, in the beginning of printing. Not there. 8th line, line number 8. Sorry, 7, line number 7 and 8, both. After print. No, here itself you can add. To this one itself, you can add that part. Print total is total. Oh, yeah, there. Within quotation, you can say total is. Close the quotation, put a comma, then put the total variable. Yes, that is correct. The average also you can print like that, then that will be a meaningful message. Yes, correct. Okay, that's it. I think let's put some numbers and see. You'll get meaningful one, right? Okay, something like this. Let me show the output. Total is total and the average. So let's say VG. I can make it shorter, right? If you want. So no need to write the entire English word. So it can make it shorter. So then divide by 3 and total is total and the average is average. Oh, sorry. Total is total. Average is, all right. So please copy down into the book. And now you can see, even though you type very large numbers, still will be added, right? Oh, INT should come there. INT should come there. Out again. Here it should be AVG. So whatever the variable that I have declared should be used. Okay, done. This is what you get. Okay, now you have idea. So what is coding and in which phase we start the coding? The planning phase is needed. The plan can be then converted to the code. Then the testing, actually testing we have already done. What we have done is testing. All right, then so if you have any doubt, you can send it to my email and I'll be sending the recording as well and also the note. So let's see you all next day and goodbye.
Goodbye.
Bye.